Okay, example 1a and 1b here, shortly after. Hopefully start off relatively easy, where we're simplifying radicals using the imaginary number. So example 1a, let's simplify the square root of negative 24. Now before we would say, hey, the square root of negative 24 didn't exist. But now we're trying to kind of narrow down that answer a little bit more instead of just saying, hey, it doesn't exist. How could we be a little more specific? And that's why our imaginary number can be a little bit more helpful here. So first of all, I have this negative under the radical. My first thought is the square root of negative 24 is the same thing as the square root of negative 1 times the square root of 24. And the square root of negative 1 here, what we just learned right above, the square root of negative 1 is I, this imaginary number I. I times the square root of positive 24. All right, so basically anytime we see this negative under the square root, we're going to pull an I out of our radical. But then we simplify our square root of 24 like normal. And whether you like that factor tree strategy for simplifying your square root, or if you like thinking of what perfect square is the largest that goes into 24, either method works. But going off of that second strategy where I think what's the largest perfect square that goes in, I know 24 is 4 times 6, and 4 is the largest perfect square that goes into 24. Okay, so the square root of 4 is 2. That comes out along with the I, so 2I radical 6. The 6 is stuck underneath stuff. Okay, so the 2I times the square root of 6 is my final answer.